Hi, everyone. I'd like to go over quiz two. So there are two versions this time. I will go over both. In the future, I'll probably just go over one version. I might actually have only one version in the future. We'll see. Um, Basically, we'll see. But yeah, I'll go over two versions, both versions. So um, yeah, so just like the homework, this problem was very similar to the homework. You can either hire 7 employees at the beginning of a 3-year period, or buy a machine at the beginning of the 3-year period. Employee costs are 6,000 at the end of each month for 3 years, and you can sell the machine for 5% of its original purchase price. What's the maximum price that it makes sense to pay for the machine if interest is 0.5% monthly? Okay, so remember, this is all an equation of value. You have to time value every single expense that you make. And the logic there is any expense, anything you pay, any expense is money that could have been invested into some account. And implicitly, that account earns 5% monthly interest. I think that is like 6.17% effective yearly interest. Um, so it's pretty realistic interest rate. Um, I mean, I think right now the stock market, believe it or not, is giving better returns than that. Just really, I don't know what the word is, crazy considering all the pain and suffering a lot of people are going through. And anyway, that's for another day. So, right. So, what are the employee costs? Um, well, let's just draw a time diagram. Um, yeah, I think drawing a time diagram here helps. Right. So let's do months 0, 1, 2, et cetera, et cetera. So all the way to 35, 36, which is 3 years. 3 times 12 is 36. So you got 6,000. You don't have to draw a time diagram. I think some people didn't. That's fine. So just like I did, just like I did in homework, I'm going to take the accumulated value of everything. Some people took the present value of everything. I'm more than thrilled if you did. Just like as I mentioned, for equations of value, it really doesn't matter all that much where your reference date is, as long as you consistently and accurately time value everything to that relative date, you're going to get the same answer. Um, yeah. So, and for these kind of problems, there's no single one obvious date. So you definitely either want to take the accumulated value or present value of everything. Otherwise, you're going to have to basically use. It's going to be a little messy if you do anything else. But anyway, so right. So you have 7 employees. Yeah, each employee is 6,000 at the end of each month. So this 6,000 earns 35 months of interest. So I don't really want to write 6,000 times 1.005 to 35. So I'm just factoring out a 6,000. But this 6,000 earns um, 35 months of interest. So it's 1.005 to 35. This 6,000 here earns 36 minus 2 is 34 months of interest. So I guess I can write everything if if it might help someone who didn't really understand how to do this problem. I'll just write things out in full detail and then factor out the 6,000. I'm not going to do this doing present value. but as I said, I'm more than happy if you correctly took the present value of everything. It's a perfectly fine way of doing this problem. So 6,000, right, this earns 36 minus 1, 35 months of interest. Effective monthly interest is 0.05%, so it's 1.005 to the 35. 6,000, 1.005 to the 34. And keep going, just do the last two, 6,000. This earns 1 month of interest, the payment at t equals 35. And then last but not least, the last 6,000, which earns no interest. Okay, so factor out the 6,000. This is 42,000. 1.005 to 35. 1.005 to 34. Keep going, until you hit, well, just 1. So this is just very simply geometric series. Sorry, I forgot the equal sign. Hopefully didn't confuse anybody. So it's 1 minus r. R is 0.005. Sorry, 1.005 is r. To the n plus 1, n is 35, so it's 36. Over 1 minus r. There's no need to factor anything. There's no need to simplify. This isn't exactly the right form you want to use a finite geometric series formula. And so inside this bracket, you get 39.33610. And you multiply this, you get 1,652,11, 16, and 20 cents. So this is for the employees. Yeah, sorry about that. I should have put that there before, but anyway, let's do the machine, and the machine is much simpler. So I think maybe a few people thought that you pay for the machine each month. There's no service fee for the machine. I mean, would be realistic that there might be. But like for example, if you own a gym, you're going to have to service, machines because people are using it all the time. So maybe every year, realistically, you have to service it. But anyway, so you just pay X at the very beginning, and then you get back 0.05x. Remember, we're dealing with costs, so getting money back is like a negative cost. As I've said before, if you want to make everything negative, if you really want to strictly make costs negative, there's just a lot of minus signs floating around, and I hate working with minus signs when I can avoid it. I'm sure most people do too. All right, so this X here, based on a timeline, earns 36 months of interest. So for the machine, we have 1.005 to 36, x minus 0.05x, and with a little rounding, 1.14668x. Glad I have some room here. So the equation of value is going to be the following. You just set the two to be equal. 1.14668. I should say someone actually recast this problem into net present value language. If you're familiar with net present value, absolutely you can do that. Basically, you would make the I mean, it's a little, I guess it's a little challenging to make it in terms of net present value because uh, there's really no revenue you're getting in. You really just are, um, you just have to, um, I guess, yeah. I mean, in some sense, you can recast this in terms of net present value, but it's not what you would traditionally think of in terms of net present value. Or I guess in some sense, yeah, I'll leave it at that. We'll talk more about that towards the end of the course, net present value. But anyway, so you just set these two to be equal, 668 x equals 1652 116 and 20 cents. And so x would be 1440781 and 60 cents. So for the other version, basically the problem is the same. Numbers are a little different. So I'll just go through this more quickly. So here it would be 50,000, 10 times 5,000. So I'll do the employees first. Sorry, 10 times 5,000 is 50,000. Same thing, but instead it's 0.04, so it's 1.004 to the 35, 1.004 to 34. Not going to draw the timeline because timeline is basically the same, all the way down to 1.004 1. Anyway, so this is going to be 50,000. 1 minus 1.004. Again, n plus 1, 35 plus 1. 1 minus 1.004. And this is going to be 1,931,905. So I should mention quite a few people, well, first of all, had kind of suspiciously the same answer, but they didn't, a lot of people did the kind of same error of not time valuing the employee costs, and they kind of, I guess, time valued the machine costs. But you have to time value things. That's like the whole point of this course. That is literally the point of this course, is that everything has to be time valued, because otherwise it's just not realistic. Again, any expense you make, any business decision you make, you could always just invest your money. So you have to always look at, well, do I do this project? Do I make this decision, or do I invest my money somewhere else? You can always invest, so you always have to time value everything. Of course, if you put in money into an account, you want to time value it and see what you get, because the account's earning interest. But yeah, so in the future, unless I specifically say do not time value something, you have to time value it, or I'm going to be extremely harsh in the grading. So again, that's the entire purpose of this course. All right, anyway, so enough of that. So for the machine costs, it's basically the same thing, 1.004 to 36. The cost earns 36 months of interest, as is at the beginning. You get 10% back. So this is 1.00, sorry, not that, it's 1.05455x. And again, this is the employee cost. And this is the machine. All right, so you set the two to be equal. 19319054223 equals 1.05455x, and x is 1,831,971.38. All right, so I'm here, so why don't I just do this problem? So the two in the different versions were a little bit different, and I think just as many people got one correct as two correct. I think two is much easier, so I was a little surprised at that, but it's all right. So I do like these kind of problems, so definitely need to get comfortable with nominal interest and really understand what's going on. And so anyway, Bank A offers 5% nominal interest compounded continuously. What is a nominal interest rate compounded every 3 months that Bank B needs to offer? So I think the easiest thing to do is basically make it so that both have the same equivalent effective annual interest rate. Let's call that I. So Bank A, well, the formula is here delta or really delta is 0.05 in the decimal, but this is nominal interest compounded continuously. That's what delta is, or I infinity, if you prefer. Some people wrote down the limit definition of I infinity. That's completely unnecessary. I mean, anyway. Right, so I is a formula. It's e to the delta minus 1. So it's e to the 0.05 minus 1, 0.05127. Some people did it a different way. That's fine. They used the PERT formula, but I don't really see the purpose. But anyway. Okay, so Bank B. Right, so we're going to use this I here. We're going to assume that these two banks have the same equivalent effective annual interest rate. So every 3 months corresponds to 4 times a year. There's 4 3-month periods in a 12-month year. So just plug into the formula using I is 0.05127. So it's I4. Remember, we're asking what nominal interest rate should Bank A offer to be competitive with what nominal interest rate should Bank B offer to be competitive with Bank A? So this is 4 times 1 plus I, 1.05127 to the 1/4 minus 1, and this is 0.050314. Right. So any smaller nominal interest rate and Bank B's equivalent effective annual interest rate will be smaller than Bank A's, and hence will be less competitive than Bank A. So this is the smallest interest rate Bank B can offer, the smallest nominal interest rate compounded every 3 months to be competitive with Bank A. And it's a little different for the other version by design. So instead, let's say Bank A offers nominal interest of 5% compounded every 3 months. So this is the percentage for I 4. So let's write down Bank second. So Bank A. So same way of doing this. Let's get what the equivalent effective annual interest rate is. Well, the formula is 1 plus I4 over 4 raised to the 4 minus 1. I4 we just had is 0.05. That. So this is 0.05095. You dump this into a calculator. It's a little crowded and messy. And let's solve for the nominal interest rate compounded continuously that corresponds to this equivalent effective annual interest rate. So actually, I should say I have to find out the median and averages. But if I had to guess, they're roughly the same as quiz 1, maybe slightly lower, maybe B, median and average. So scores were overall pretty good. Cannot complain. Right, so remember the formula is, and I don't care if you call it delta I infinity, whatever. It's ln of 1 plus I. So here, it's different. Here, we're given delta, figure out what I is. Here, we're given I, figure out what delta is. And you could solve, you could use one formula, solve for I by taking exponentials, or use another formula, solve for delta, take the logarithms, add one, take logarithms. I think it's just easier to memorize these two formulas, but up to you. Anyway, so this is ln of 1.05095, and this is going to be 0.04969. And again, the practical interpretation is if Bank B offers a nominal interest rate compounded continuously lower than 4.969%, then the equivalent effective annual interest rate for Bank B will be less than that for Bank A, and hence Bank B will be less competitive than Bank A. And sorry, this is a 9 here, 0.04969. So any questions on this quiz, let me know. And remember, there's another quiz Friday, and the exam is creeping up on us. It's going to be on Friday, March 5th. So yeah, same format, but 6 problems. You have 7 hours from noon to 7. So and that's messy. This is an equality sign. There should be any confusion, but it's so long. Take care. Yeah, bye-bye.